All right, welcome. We're going to jump straight into a pretty tricky 4-mark GCSE maths question today. Our plan? We're going to decode this thing piece by piece, and I'll show you exactly how the official mark scheme breaks it down so you can see where every single mark comes from.
Okay, let's get right into it. So here it is, question 22 from a higher tier non-calculator paper. And yeah, I get it. At first glance, it looks, well, pretty intimidating, right? You've got all those square roots, or surds as we call them. But trust me, stick with me on this, and you'll see it's really all about following a clear step-by-step process. So here's the challenge. The question gives us the second and third terms of something called a geometric sequence. And our job? Find the common ratio. Simple enough, right? Well, there's a catch. We have to give the answer in a very specific format. And, this is super important, it says we must show all our working.
Okay, so what even is a geometric sequence? Well, the key idea, the whole secret, is that to get from one term to the next, you're always multiplying by the exact same number. Always. So to get from our second term to the third term, you just multiply by this common ratio. And honestly, that little fact right there is the key that unlocks this whole problem.
Right, let's get into our game plan. First step, how do we lock in that very first mark? This is all about showing the examiner, hey, I get the big idea here, even before we crunch a single number. And here's the first move, laid out perfectly. Think about it. If you multiply the second term by the ratio to get the third term, how do you work backwards to find the ratio itself? You do the opposite, right? You've got to divide the third term by the second term.
And believe it or not, that's it. That's the first mark. Just by writing this down, just setting up the division like this, you're proving you've understood the question. The mark scheme calls this a P1 mark, a process mark, and you've just earned it. See? We're already on the board.
Okay, now we've hit our first real roadblock. We've got our fraction all set up, but look at the bottom. There's a surd, that pesky square root of 2 sitting in the denominator. And in maths, that's a big no-no. We just can't leave it like that. So, what do? How on earth do you divide by something that has a square root in it? Well, there's a special technique for this, a specific tool in our mathematical toolbox. And for a non-calculator paper, knowing this is absolutely essential. It's called rationalizing the denominator. Sounds fancy, but all it really means is getting rid of the square root on the bottom of the fraction. And the way we do it is kind of clever. We multiply both the top and the bottom of our fraction by something called the conjugate. Now, what's a conjugate? It's super simple. You just take the denominator, in our case 3 plus 2 root 2, and you flip the sign in the middle. So it becomes 3 minus 2 root 2. And just by setting up this multiplication, you've shown the examiner you know exactly what to do. And bam! That's your second process mark. Another P1, locked in. Okay, time to get our hands a little dirty. The next bit is just some number crunching. We're going to break it down into 2 manageable chunks. First, we'll expand the top of the fraction, the numerator, then we'll do the same for the bottom, the denominator. This is where being careful and paying attention to detail really, really matters. Right, let's tackle the top first. We've got to expand these brackets. So 13 times 3, that's 39. Then 13 times minus 2 root 2 gives us minus 26 root 2. Next up, 9 root 2 times 3 is a positive 27 root 2. And now for the trickiest bit, 9 root 2 times minus 2 root 2. Okay, let's break that down. 9 times minus 2 is minus 18, and root 2 times root 2 is just 2. So we have minus 18 times 2, which is minus 36. Whew. Okay, now for the bottom. And I want you to watch this, because this is where the magic happens. So 3 times 3 is 9. 3 times minus 2 root 2 is minus 6 root 2. Then 2 root 2 times 3 is plus 6 root 2, and finally 2 root 2 times minus 2 root 2 is minus 8. Now look, see that? The minus 6 root 2 and the plus 6 root 2, they just cancel each other out completely. That's not a coincidence. That is the entire reason we use the conjugate. It's designed to do that. So let's tidy this whole thing up. On the top, we've got 39 minus 36, which is 3, and minus 26 root 2 plus 27 root 2 leaves us with just a single positive root 2. And on the bottom, 9 minus 8 is just 1. Easy. Now, here's a cool thing from the mark scheme. Just for doing all that expansion work, even if you made one tiny slip up, you'd still get the method mark, an M1. That's your third mark in the bag. We are so close now. Seriously, all the heavy lifting is done. We've shown our process, we've done the rationalization, we've expanded everything out. All that's left is to write down the final answer exactly how they asked for it. And there we have it. 3 plus the square root of 2, all divided by 1, is just 3 plus the square root of 2. It's perfectly in that a plus b root 2 format they wanted. And getting that final correct answer nabs you the A1, the accuracy mark. And just like that, 4 marks secured.
So we got the answer, which is great. But hang on, before we wrap up, there is one more thing. And honestly, it might be the most important lesson from this whole question. It comes straight from the examiner's mark scheme. Just let that sink in for a second. You could be a genius and just know the answer is 3 plus root 2. But if you just write that down with no working, you get 0 marks. Nothing. It shows that in these questions, showing your steps, the division, the rationalizing, the expanding, isn't just a good idea, it's everything. The journey is what gets you the marks. And that right there is the big takeaway. It's not just about being right, it's about proving why you're right. So the next time you're staring down a complex problem, just ask yourself that one question. Is my working clear enough to earn every single possible mark? That's what makes all the difference.